Hey guys, welcome back to the next video. Now in this video, we will be implementing this particular argument in our JVM. There are these two arguments which was missing over here. So now that is removed because of the this version of WebSphere or the Java does not compatible with the options. But majority of the options is over here. So we have the minimum maximum total size of the JVM heap size. We have the young generation or the nursery generation maximum size allowed. And I've reduced it to 256. It was 512 before. The thing is that it needs to be below the minimum memory over here. So the minimum memory is 512, so 256 should be sufficient. And the survivor space should be is 8. I've not changed it. I've now changed the LOA allocation as well to 0.3 and 0.5. SOA will be allocated automatically. We don't have to specify the amount. So just like copy this and what you can do is like we can just go ahead and put this on our console. So where do I put it on the console? Just go to the server and then go down to Java process management, go to process definition. And then on the right side, select Java virtual machine. And you will see an option called Java JVM argument. So just copy paste it and just click on OK, review, save the changes. Now you need to restart the server. So let's go ahead and restart it. So let's stop it and then start it up. I'm going to pause the video. Okay, if your JVM didn't come up, suppose like there is some error. So it is throwing up an error over here and your setting is wrong, of course, then you'll not be able to access a console, right? So now how to fix it? Very simple. Go back to another tab, open OPT IBM WebSphere application server, profiles, app server profile. And in here, go to config folder, cell name, nodes node name. As this is a server related configuration, it's on your server JVM argument. So it will be inside your servers folder and then the server name. Choose the appropriate server which you have just done the change and then open the server.xml file. Now server.xml file will hold all the JVM variables, all those things. So open that over and in the bottom, almost in the bottom, you will see the JVM, generic JVM arguments. So these are the values which you have entered, right? So just correct the value. If you're not sure the error will be displayed on your logs on the native error log file. So there will be a native std out or error. So open that log file and you'll be able to understand the error and then you can fix it. And once you have done the changes in this file, then save and quit the file and try to restart it again or remove the changes after all and see if that works. So you can just go ahead and remove the changes which you have done and you can see that your server would come back up without any issue. But for me, I had no issues. I think the server started back up. So let's just go over here. Okay, I'm able to log into the server. So this is a good thing. So now let's go ahead here and then type ps-e of grep of Java. Now when I do grep of Java, now you see that the default setting is gone over here, but I do have this compression and class AOT and class cache. So that should be fine. And here, if you see over here, so now after this, right? Over here, XMX, I think I did the font change, so it is not coming up properly. Okay, here XMS 512 MB, XMX 2048 MB, which is 2 GB, XMN 256 MB, survivor ratio 8, and you have XM inf is 0.3 and XM Xmax F is 0.5. So this is pretty much what we have given so far. So now it just started to work fine. So another way to verify this is by looking at your verbose GC. So open your verbose GC 5.log, which is the latest one. So when you go on the top, you just keep coming bottom. You will see the latest update over here. You can see that here. This is our latest update. It just talks about your minimum maximum memory as well as your nursery space, survivor ratio, and your LOA free space. Okay. So now over here is actually your garbage collection. This is the first garbage collection which happens right after you start the JVM. Now, when you start the JVM, you will see a lot of garbage collection information. But this is the scavenge collection. Okay, so this is basically called as a local collection or partial garbage collection. This is not a full GC. Full GC happens, and the log output of that exclusive start and exclusive end will be really longer than this. So if you find this itself is a long, so this is your exclusive end and this is your exclusive start. So if you find this long, the full GC will be even longer than this. Okay, so this is a scavenge GC, which is a partial GC. Okay, now what this does, scavenge GC, is basically for your basically happens when your nursery is full. Okay, now you can see the nursery is full because you see the percentage of availability of free is 0. Okay, so that's the reason why it's happening. So if you see this total memory, the total memory is 536. Okay, this is in bytes. Okay, so copy this and put it in a Google byte to MB converter and then paste it, and you can see that this is 536 MB. So 536 MB is almost like your minimum space, which is about 512, and we have given 256 MB for our, you see that 256 MB for our nursery area. Okay, so which means this should be, it's around 256 MB. Okay, to be, it won't be coming in precise, but then it's around that 256 MB. Now your nursery space is fixed and rest of it gone to tenure space. Okay, tenure space has SOA and LOA. LOA is less and SOA is high. This is the default partition, the default split between LOA and SOA. So this basically tells you what is the allocated space. But do remember, this is this is only for the minimum 256 MB. It will expand till maximum given the scenario of increased occupation. Now, scavenge type of garbage collection triggered because your nursery is out of memory. Okay, so what it will do, it will basically clear this memory and move objects to your tenure space or in the SOA or LOA, looking at the size of it. Okay, so you can see that this is your scavenge in terms of gathering the data. This is your, it has looked upon and it has actually gathered the evidence of what it is currently having. Now the actual allocation in terms of the freeing of memory happens over here at the second part of your garbage collection. It basically understands the references over here. We'll talk about references on the next garbage collection video. It looks upon 3 different references and then basically understands the candidate for clearing. This is called the marking phase. So marking phase happens in scavenge also, and then this is basically your sweeping phase, wherein which you can see that it has removed certain candidates over here, where it has identified that those objects are not referred anymore, so it needs to be removed. And you can see that post garbage collection, it took about what, 40 seconds duration in milliseconds, 40 milliseconds it took about. And what it has done is like it has reduced the occupation over here. So you can see that the nursery space has 40 percentage free space right now. Allocation is 80 percentage free, and survivor space is 0 percentage free. Everything is occupied on the survivor space. But slowly you can see that it has gone to 97 percentage on SOA. Now when I sort it by SOA, right, you will slowly see that the SOA percentage will decrease because more and more objects are being used and the object is collected in the scavenge. And when the scavenge collects the garbage and it has this permanent object, right, it will slowly move it to SOA. Okay, so if you see that SOA, so 96, it has gone lower because it is moving that to the SOA. So if you just keep going down, you can see that it has gone to 88 percentage of free space in your SOA. So likewise, you will see the reduction in this one until a point where the full garbage collection is triggered. Okay, but that will take a long time because it was reducing very slowly. You can see that one person by person is reducing because of the new objects being moved to the SOA space. So If you go to the end, right, you will see the new objective coming over here. So right now there is no garbage collection happening because I'm not giving any kind of a workload to the JVM. The more the workload I give to the JVM, the more the process it does, the more the garbage collection happens over there. So if I'm giving more workload, I'm just refreshing this page, I'm doing something to this. So this activity becomes stuff, and then basically a garbage collection is called upon. After this many milliseconds, the garbage collection is called upon. And again, you can see the addition to the SOA over here, and reduction of free space in addition of free space over here. You will see a lot of addition over here, but a reduction of free space because all those objects are moving over here. But if I run a full GC, you will see the SOA will reduce, because full GC means the GC happens not just in the nursery area, but it will also happen in the tenure area as well. But in terms of large object allocation, there's not much use because my application is like SOA based, because I'm creating all small objects. I'm not creating large objects. So in this case, I can even disable my large object allocation, and I can make this 0. So I can give more concentration of memory towards the SOA where my actual data is needed. So it is not a privilege to have an unutilized or unused memory part in your application. So do remember to verify your application, verify what kind of a garbage collection is going on your application, see which memory you can give, talk to the developers and sort it out, because this is one of the ways that you can actually utilize that memory, because my memory currently on LOA is not being used for the last 15 minutes I've worked with my application. So this waste memory is completely waste. It's of useless. So think about that, and this is how we need to work with it. If you have any questions, please leave it on the question section. I'll see you on the next video.